On this worksheet, we're going to practice doing unit conversions between moles and grams and atoms. And let's just jump in with the first problem. So the important thing that I want to remind you when you're working on these problems is that you want to treat these problems just like any sort of unit conversion. Like if you were being asked to convert from centimeters to meters or from miles to kilometers, the strategy that you would take for those types of unit conversion problems, exactly what you're going to do here. Even though it's, feels like it's completely different, it's still the same process. So that means we want to start by writing down the number and the unit that's provided to us in the problem. And it's also going to be important for us to get in the habit of writing the symbol of the atom as well. So not just the unit, but also what the atom is. And then we want to set up a unit conversion. We want to multiply the 2.109 grams of beryllium by a conversion factor that has grams of beryllium on the bottom so that those units will be able to cancel out. And then up on top of the conversion factor, we want our desired unit, moles, which we abbreviate MOL, of beryllium. Now we just need to come up with the relationship between grams and moles. That number comes from the periodic table. So what we want to do is go find beryllium on the periodic table. And what we're looking for is not the atomic number of beryllium, but the other number. So this other number here is the mass, the atomic mass. And this is telling us that there are 9.012 grams in 1 mole of beryllium. That's how we interpret that. So that means that 1 mole of beryllium is 9.012 grams. And since we've got this problem set up correctly, the units grams of beryllium will cancel out. And we just do the math at 2.109 divided by 9.012. Well, that's weird. Those are the same digits. That's a coincidence. We get 0.2340 moles of beryllium. In the next example, we are starting with the number 2.0. The unit is grams of potassium, and this time we're being asked to convert that into atoms. So we want to set up a conversion factor that lets us cancel out the units of grams potassium. One of the kind of tricky things here is that if we're in units of grams, the only option that we have is to convert into units of moles. And that isn't the unit that we want, but that's fine. That just means we're going to have to take a couple of steps to solve this problem. So here's potassium. There's its atomic mass, 39.098 grams in a mole of potassium. That cancels out that gram unit. Now, to get from moles of potassium to atoms, we want to set up another conversion factor that's going to let us cancel out that mole of potassium and convert into our desired unit, atoms of potassium. This conversion factor is done using Avogadro's number. 1 mole of anything is 6.022 times 10 to the 23rd of that thing. So in this case, 1 mole of potassium is 6.022 times 10 to the 23rd atoms. And again, this is the step you're going to have to take every time. So when you're starting with units of grams, your only option is to convert into units of moles, and then you can convert from moles to atoms. The math here is going to be 2 divided by 39.098 times 6.022 times 10 to the 23rd. And I am getting 3.1 times 10 to the 22. My units are atoms of potassium. For this next one, we're being asked what the mass is of 0.5 moles of zinc. So we're going to start with the number, the unit, and the atom that's provided to us. We want to multiply by a conversion factor that has moles of zinc on the bottom. When we have units of moles of zinc, our options are to convert into either atoms or grams. In this case, we want to convert into grams because that's what the problem is asking us to do. And maybe we just kind of make a note of that. If we're starting with grams, we can only go to moles. If we're starting with moles, we can go from moles to grams, or we can go from moles to atoms, either one. If we're starting with atoms, our only choice would be to go to moles. Okay, so to fill in this conversion factor, we're going to need the information for zinc. So let's find zinc right here. Its mass is 65.38. That means 65.38 grams in a mole. The moles of zinc unit will cancel. And this is 0.5 times 65.38, 32.7 grams of zinc. And we have one more to go. This one is asking us what the mass is in grams of one atom. So we're starting with 1. The unit is atom, and the atom is gold. We want to multiply by a conversion factor that cancels out the units of atoms of gold, so that's going to be on the bottom. And if we're starting with atoms, our only choice is to convert into moles of gold. To do that, we're using Avogadro's number. 1 mole is 6.022 times 10 to the 23rd atoms. Doesn't matter what kind of atom it is. It's the same number no matter what type of atom. And then we want another conversion factor that has the moles of gold on the bottom and convert into grams of gold on the top. Let's find for gold AU. The mass is 196.967 grams per mole. And this is 1 divided by 6.022 times 10 to the 23rd times 196.967. And I am using the calculator on my phone, which I don't always hit the buttons correctly on this. So this could be wrong, but hopefully close to right. 3.271 times 10 to the negative 22. I was hesitating there for a second because I was thinking about significant figures. How many sig figs should I have in my answer? This is actually kind of a tricky one because one atom has infinite significant figures because it is a counted number, not a measured number, meaning that we know that there's exactly one atom, like exactly one. So it has an infinite number of zeros at the end of this. So there's infinite number of sig figs. So then that would mean that I would be dictating my answer by the 4 sig figs that are in Avogadro's number, 6.022.